In step 5 of exercise number 6, the following actions have to be implemented to complete the machining of the triangular pocket. An iRough and iFinish operation must be defined. During this step, the efficiency slider is used for morphing spiral controls to demonstrate its effect on the iMachining toolpath. First, you have to define the rough machining of the pocket. Add a new iMachining operation. In the SolidCAM manager, right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed, and the default iRough is used for technology. On the geometry page, click the New button to define the machining geometry. For this operation, the geometry is defined as a closed pocket with entry chain. In the SolidWorks graphics area, first pick on the top edge of the pocket contour as shown. Select Auto Constant Z to close the chain, and then click Yes to confirm the chain selection. Next, pick on the top edge of the through-hole contour as shown, and then click Yes to accept the chain selection. In the chain list, right-click the entry chain, Chain 2, and choose Mark Chain as Open. The geometry is defined. Click OK to confirm the geometry selection and exit the Geometry Edit dialog box. Switch to the Tool page and click the Select button. In the Part Tool table, select Tool number 4, the 14mm bullnose mill. Click the Select button to choose the tool for the operation and exit the Part Tool table. Switch to the Levels page to define the milling levels. Click the Upper Level button. In the SolidWorks graphics area, select the top face of the target model as shown, and then click OK to confirm the selection. Next, click the Pocket Depth button and select the lower face of the pocket as shown. Click OK to confirm the selection. On the Technology Wizard page, the default cutting conditions are used with a machining level aggressiveness of 6. Switch to the Technology page. By default, a 0.24mm allowance will be left on the walls. In the Morphing Spiral Controls area, there is a slider called Efficiency. This slider enables you to control the efficiency of the morphing spiral toolpaths generated by iMachining. For the purpose of this exercise, reduce the efficiency slider to level 1. Name the operation iRough Pocket. Click Save and Calculate, and then click Simulate. Click the Play button to view the iMachining toolpath. iMachining generates morphing spiral toolpaths with different side steps in different directions, whenever it needs to clear a completely open or closed pocket area that does not have the shape of a circle. With a low efficiency setting, iMachining uses more of the stepover range specified by the Technology Wizard. As you can see, by managing to morph itself into the narrower parts of the pocket, the spiral produced looks less like a circle and covers a greater part of the area. Close the Simulation Control Panel with the Exit button to display the Technology page of the iMachining operation dialog box. In some cases, where the average side step is smaller than the maximum side step, a morphing spiral could potentially be less efficient than a regular round spiral. For that reason, you can limit the morphing by selecting a higher level of spiral efficiency. For example, increase the efficiency slider to level 10. Click Save and Calculate, and then click Simulate. Click the Play button to view the iMachining toolpath. With a high efficiency setting, iMachining reduces the variation of stepover range permitted in the spiral. As you can see, the side steps in all directions are more equal, and as a result, the spiral produced looks more like a circle and covers a lesser part of the total pocket area. The remaining areas are cleared with trochoidal-like toolpaths. Close the Simulation Control Panel with the Exit button to display the Technology page of the iMachining operation dialog box. Lower efficiency levels will yield a longer tool life, while higher efficiency levels in some cases yield a higher average material removal rate. For this operation, set the efficiency slider to level 6. Currently, this is the default position and is recommended. Click Save and Calculate, and then click Simulate. Click the play button to view the iMachining toolpath. The tool feeds down and performs the morphing spiral toolpath to the outer walls of the pocket with an efficiency level of 6. Close the Simulation Control Panel with the Exit button to display the iMachining Operation dialog box. To perform the finish machining of the pocket, you have to define an iFinish operation. Click the Save and Copy button to create a copy of the current iMachining operation. When the copied iMachining operation dialog box opens, click the drop-down menu under Technology and change the operation type to iFinish. The copied machining geometry, 14mm tool, and milling levels from the previous iRough operation are used for this iFinish operation. On the Technology Wizard page, the default cutting conditions are used with a machining level aggressiveness of 6. On the Technology page, the wall island offset is now set to 0 by default. At this point, the operation can be calculated, and the iMachining toolpath can be viewed on the model. Name the operation iFinish Pocket, click Save and Calculate, and then click Simulate. Click the play button to view the iMachining toolpath at work. The tool feeds down and performs finishing of the corners first, and then finishes the walls by removing the 0.24mm offset in a single pass. Using the Exit buttons, close the Simulation Control Panel and the iMachining Operation dialog box. At this stage, Step 5 is complete and the efficiency slider was used to demonstrate its effect on the morphing spiral toolpath. If you have not followed along, apply and practice the procedure shown in this video to define the rough and finish machining of the triangular pocket.